Here's a PNY flash drive that's using a Toshiba flash controller. So the fun thing here is that Toshiba doesn't actually manufacture any of their USB controllers, at least none that I'm aware of. They use other companies' controllers and sell them as their own. So Silicon State Systems and Phison are usually the two that are used. This has a broken connector, but there's a little bit of a twist. So I'll attach a new USB connector. Sometimes replacing USB connectors on these can be really simple, but sometimes if the drive breaks at exactly the wrong time, you can actually end up with corrupted information when you plug the flash drive into a computer, in which case a little bit of extra work is needed to get the data off. So everything looks good. And let's move over to the computer. Sometimes when we get a broken connector case in, it's more than just a broken connector. For example, sometimes the information is corrupt, which requires either file system recovery or an off-chip recovery. In this case, it's a file system recovery. This can happen if the flash drive was being written to at the exact moment when it was broken. So this can be either a write from the operating system updating information or a write from the flash drive doing some internal maintenance, like erasing various blocks and whatnot for wear leveling. Anyway, so to start off with the file system, what we do is we mount the flash drive, and what you'll see is that the flash drive has a bunch of garbage for the label, and if you open it, you see the same garbage. That usually means that the root directory is trashed. So what the root directory is when you open up, let's say, your C drive or your flash drive or whatever, the first files that you see here are the root directory. So everything begins at the root directory. Think of it kind of like a tree, and it kind of branches off with the kind of like different nodes and whatnot. So the root directory is kind of like the starting point for where everything spreads off of. Think of it kind of like a tree where you have like the different branches all stemming from the same trunk. So let's say you open the C drive. All these entries right here are all connected into the root directory. So if we look at the flash drive itself and open it up in Image Explorer, we see that it comes up as 8 gigabytes, which is important because it means that the flash drive is at least being recognized by the computer properly, and it's booting up from the controller on the board itself. So if we open it up, first thing we notice that the boot record over here is completely trashed. But at least the pointer to the FAT32 file system is good, and even the FAT tables themselves are good. If we open up the properties, we see it's pointing to the right root cluster, which should always be 2 on a FAT32 file system, and it's saying that this is cluster number 0. If we do check DIRs, the difference should be 0 if that number is correct, which it is. Just means that everything is pointing to the correct location. So for instance, cluster number 324 should be in this location here, should be in this location here, and it's in this location, which is correct. There's no difference. But if we open up the root directory over here, we see it's just full of garbage. So we have to reconstruct the file system. There are a couple utilities that you can use. You can try doing it in Image Explorer. Another one is Get Data Back. But in this case, RStudio gives us the best result. RStudio is a popular application used by data recovery companies. It's pretty actively developed, and it specializes in doing raw recoveries as well as file system. It's not perfect, but it works pretty well. What we'll usually try doing is running multiple utilities and see which one gives us the best result. So in this case, I already made an image of the drive. Ideally, you should work with an image versus the actual drive itself, because if the actual drive itself fails for whatever reason, at least you have some data that you've copied out of there. Or if you need to make modifications in some way to try and get a better quality image, you should do them on the image versus on the drive itself. And what an image means is that you're doing a one-to-one copy of the information. So you're literally extracting every byte of information from the source media onto a file. And you can do that with RStudio, Image Explorer. There are a lot of different ways. In Linux, you can do it with DD or DD Rescue. All right, so you want to open up the image file, which you already copied onto the desktop. And we're going to do a scan. And because it's an image file, it also works a lot quicker because a flash drive, especially USB 2.0, is pretty slow. And this is 8 gigabytes worth of data. And all these little markers over here are either directory entries or file markers or whatever I was able to find. So if we open up the directory structure that I was able to rebuild, you still have all this garbage in here, which is just pointing to nothing. So that's pretty much useless. In this case, we had to do a raw recovery. So with the raw recovery, we were able to get all this data, but the caveat being that it loses all of its file names. Sometimes those file names can be grabbed from metadata, but oftentimes you either need to open a file, all the files one by one to find the information you're looking for, or to use an application or the Windows indexing service to try and find keywords or phrases from each file. So that way you can try and rename the files or recreate the folder structure. But in cases where you have no other option, it's the only way to pull the data off the drive. So I hope this helps you see some of the things that we have to go through when we're doing broken connector repairs or in some cases off-chip recoveries.